Hi there, in this screencast I'm going to be showing you how to use keras and R to demonstrate overfitting with the neural network model size. So in previous tutorials we saw how to load the keras library in R, and when I tried to do that same thing on this computer that I'm using at home to do this screencast, I noticed that there was some issue with TensorFlow crashing and then some keras problems. So anyway, I got it to work by looking at this GitHub issue and using this install keras line along with these keras use implementation and use backend calls. So if you have that same issue, you might try that. This seems to only happen on older computers. Anyway, so what we're going to do first is, so the goal of this screencast is to show you how to use the keras library to train a neural network and to demonstrate that the neural network number of hidden units in the neural network is a regularization parameter. So how do we demonstrate that the number of hidden units has a regularizing effect? Well, we have to analyze the validation error as a function of the number of hidden units. So let's do that. First thing that we do is, here I'm going to download the spam video if I don't have it. Second thing, I'm going to use data table to read the spam data into R. Here I'm going to use set seed to set the random seed, then assign a vector of fold ID numbers to each one of the observations. Say that test fold is fold number 1. Then here I'm going to define a couple of variables, is train, is test, to subset my data. Here I'm going to scale the inputs in the spam data set to get this XSC matrix. Then I'm going to get X train, X test, Y train, and Y test. And so yeah, at this point what we're going to do is we're going to fit a bunch of keras models to the X train and Y train. So this is X train map. This is a numeric matrix with 3,680 rows and 57 columns. The different rows are for the different observations in the spam data set. The different columns are for the different features of each email. The Y train is a vector of the same size, so it's got 3,680 observations, and that's 2,227 zeros, that's not spam emails, and 1,453 ones, that's spam emails. So our goal is to train a binary classifier for predicting which one of these messages are spam or not. And we're going to do that with a bunch of different neural networks of different size to demonstrate the regularization effect of the number of hidden units. So here, first thing to do is I wrote this cut hidden units vec gets 2 to the seq 1 to 10. And so what that does is it gives us this vector of hidden units to try, starting from 2 and going all the way up to 1,000. And so then what I'm going to do is I'm going to do a for loop over those different hidden unit numbers. So here is for loop. I have 4 net size in blah blah. So let's rewrite this. So first thing, what we're going to do inside of this for loop is, here we're going to initialize a keras model. We're going to train it on the X train and Y train here. And then we're going to save the results in a data table for further analysis. So here I call this split metrics list. Let's call that, yeah, I guess we can keep it like that. So I mean, this was copied from the previous screencast where we were analyzing the different error metrics as a function of the different splits. Here we might call this, instead of split, I'm going to do a find and replace. to replace split with units metrics list, and now that's a little bit more informative variable name, because here we're talking about the metrics for the different number of hidden units. And so here what we're going to do is, now we're going to do a for loop for each one of these values of hidden units, right? For hidden, let's call it hidden units I in seek along hidden units vec. So this is going to give me an integer from 1 to 10 for every element of these guys. And so here we're going to say, let's call hidden units gets hidden units vec, hidden units I. And so what are we going to do in there with that hidden units value then? We're going to do hidden units equals hidden units, and then in this keras sequential model. So here I'm using this layer dense to say that we want a fully connected neural network, where the first layer here, the first hidden layer here, it has input shape, which is equal to the number of columns in the training data. That's the number of features. The number of hidden units here is going to be variable, because we're going to be studying the regularization effect of that parameter. Here we're going to use the sigmoid activation function, and use bias equals false means we're only going to be learning weight parameters, not bias or intercept parameters, as in previous coding projects. So let's execute that line of code and see what happens. So first of all, hidden units I equals 1. So that'll be the first iteration through that loop. So what do we get when we execute that first line of code? So, well, first of all, it takes a little bit of time to initialize, because I think this is the first call that we're making to TensorFlow, so it has to start up the Python interpreter and all that stuff in the background. Here we get some are safe to ignore. But let's see what this model object looks like now. So this says that the model that we've defined has 2 layers. The first one is this dense 1 layer, which has output shape of 2, so that's 2 hidden units, and it has 114 parameters, because that's the number, right? So that's 2 times the number of input units. Remember that ncall x train map is 57, so we need to learn 1 weight for every combination of inputs and outputs there. Then after that, in the second layer, what we're doing, the output of the second layer is the probability that we want to predict of the email being spam or not. And so there's only 1 value there. And the number of parameters here is 2, because there's 2 hidden units in the previous layer. So the total number of parameters to learn is 116. And so let's see if we can train that small model. Alright, so I execute this line of code like in previous screencasts. It's reporting what the train So yeah, it's only reporting the train accuracy, not the validation accuracy. That's because during that find and replace operation, there we replaced validation unit. We replaced split to unit. And so actually this should be validation split, right? It's consistent with the previous tutorial. Yeah, right. So we have validation split. That's the name of the parameter that we want to use to specify the proportion of validation samples. I mean, because we specified that other argument, which for some reason didn't give an error, here we just will have information for the train error and not the not the other, not the validation. So let's rerun that again so we get both. So it'll take a random split into train and validation. And so here, typically we will see, the train error always decreasing as a function of the number of epochs, whereas the validation error should decrease and then start increasing when, that we've overfit the training data. But here with only 2 hidden units, I'm not sure that we will even see the overfitting. So here what we see is that so in the top plot we see a plot of the loss versus the number of epochs, and bottom plot we see the accuracy. And so what we can see is that the training accuracy goes down a little bit, and the validation accuracy, the training loss goes down a little bit, and the validation loss actually increases. So this kind of strange result. Usually our rule is pick the regularization parameter, pick the parameter number of epochs, which minimizes the validation error. So here, in this case, we should actually pick the null model, basically, the random initialization, because that's the minimum validation error. So, this is kind of an indication that the number of hidden units that we've used is too small. So, in the next screencast, I'll go over what this looks like when we use a larger number of hidden units.